Yeah, good morning, students. So today we are going to see an expected 21 questions for NEET in the chapter of dual nature of radiation and nuclear physics. Nuclear physics. So today we are going to discuss only some 10 questions which is so important, which I am expecting this year. So I'll go with the first question. The first question is, I'm just going with the shortcut method. I'm not going to use any formula now. See the question here. When the light of frequency, please write down this question. When the light of frequency 2 mu naught where mu naught is threshold frequency is incident on a metal plate. The maximum velocity of electron, the maximum velocity of electron emitted is nu 1. So it is V1. When the frequency of the incident radiation is increased to 5 nu naught, the maximum velocity of electron emitted from the same plate, the maximum velocity emitted from the same plate is V2. The ratio of V1 to V2 is dash. You will be given 4 options. A is 1:2, B is 1:4, C is 4:1, D is 2:1. It is very, very important expecting NEET questions. So you cannot expect the same number, but you can expect some other numbers in the same model. So now we are not going to use any formula. So now we are going for shortcut method. Shortcut method. What is that shortcut method? Now let us see now how we are going to find. You just see, first write down what is the given. Yes, given ratio of V1 to V2. So you can write first V1 by V2. Then put is equal to. Just see what is the number here. What is the number here? If it is 2, you write down 1. Then again you see what is the number here. If it is 5, you write down as 4. You got it? If it is 2 means you have to write the before number. If it is 5 means you have to write the before number and you have to divide it. Take a square root. For all the sums in this model. What is the first step? The number before 2 divided by the number before 5. Then take square root. The answer will be 1/2. So you are getting within a fraction of second and within a single step. So 1:2 is the answer. So our option lies in option A. It's a very, very important question. It's very, very important. So let us go with the next question in the nuclear physics. So this question comes under dual nature of radiation. It comes under dual nature of radiation. Today's first question in dual nature of radiation has been finished. Now we are going for the second important question, which I am expecting this year. So let us go for the second number 2, question number 2. So the question number 2 is the off-life time, the off-life time of a radioactive isotope. X is 20 years. It decays to another element Y, which is stable. The two elements X and Y were found to be the ratio of 1:7 in a sample of given rock. Now let us see what is the question. The age of the rock is estimated to be, the age of the rock is estimated to be dash. Option A is 80 years, option B is 100 years, option C is 40 years, and finally D is 60 years. So this question also, we already done this type of question in my channel before, but I am expecting this year this important question. It's a very important 2021 expected question in nuclear physics, So this is very important question. So I am not going to use any formula. Now again we are going for shortcut method. To go into the shortcut method, what you have to do is first see the ratio. This is the sum of ratio, and he is asked to find the age of the rock. First see the ratio, add this ratio, add the ratio 1:7, that is you get 8. Convert in terms of cube, you get 2 cube. If it is 16 means you can write as 2 power 4. Now you have to add these two, you will get a number. That number has to be converted into multiples of 2. The sum will be given in the value of multiples of 2 only. So there is no need to worry, so that you just encircle this power number 3. So this is called tricky number. Now the question asked is age of the rock. To find the age of the rock, you write down this number 3 here, multiplied by half-life. He has given half-life. How much? Half-life is 20 years. So here I can multiply 3 into 20, which will give you 60 years. So now let us see where is the option lies. So the option lies in option D. It's a very important model. It's a very important model. I'll go with one more question, because since I have given it's a very important model. For your practice, I will give you one more sum. You please comment in my channel area. I will rub the options also. So I am just giving it is 1:15. Please note it down. And the options are 150 years, and also the element 20 years I am rubbing it. I am giving it as 50 years. So here 150, 200, 250 years, and finally it is 100 years. Please comment the answer in my channel area, or now if it's possible to do in chat box. So it's a very important one. So let us go for the third question now, which is there in dual nature. Now we are going for a dual nature radiation, important question. See, let us go for the dual nature. So, a graphical sum is very, very important. So, they will ask you a graphical sum 100% without doubt. But now we are discussing a important question in dual nature, that too with a graphical one. See here, it's a very important one. Which of the following figures? Which of the following figures represents the variation of particle momentum and the associated de Broglie wavelength? So, option A, it is a diagram, a graphical representation. This is lambda and this one is P. The second one, B. This is lambda and this one is P. C, option C. This is P and this is lambda. Option D. A diagram is like this. This is P and this is lambda. Okay. Now we have to find the answer, which is the correct figure for this. See, we know that de Broglie has given a clue called de Broglie wavelength. De Broglie wavelength is given by the formula lambda is equal to h by p. If you cross multiply, we get p lambda is equal to h. That is, p lambda is equal to constant, I can write. So, the same p is a variable and lambda is a variable. See, let us substitute for p as x and lambda as, so p lambda as x and p as y. So, if you substitute here, I will get x into y is equal to constant. Say xy is equal to constant is an equation of a rectangular hyperbola. It is an equation of a rectangular hyperbola. Don't forget. So, xy is equal to c square is called the rectangular hyperbola equation. C square is constant. Now, you tell me which figure represent rectangular hyperbola. So, the rectangular hyperbola figure is the option D. So, our answer will be option D. It's a very important question. Very, very, very important one. Let us go for the fourth question in nuclear physics, which is important too. Let us go for the question. Yes. Two radioactive substance, sum number 4 I think. Two radioactive substance. Capital A and capital B have decay constant phi lambda and lambda respectively. At t is equal to 0, they have same number of nuclei. The ratio of number of nuclei of A to those of B will be 1 by A square after a time interval. After a time interval, option A 4 lambda, option B 2 lambda, option C 1 by 2 lambda, option D is 1 by 4 lambda. This is an important question, so important, very important one. So this particular question has already been taught in our channel so many times. This is very important one. So expected 2021 NEET question. Which lesson? Nuclear physics. So important. So shortcut method. Let us go for shortcut method. So what you have to do is, you subtract this 5 lambda and lambda for all the sums. 5 lambda minus lambda will be equal to, then what is the value here? The value is number is C here. It is 1 by E square. So now instead of writing 5 minus lambda, see what you are going to do is, first you write down that number 2. Okay, divided by, see the question asks this time t is equal to, write down this number 2, because 1 by E square. If it is 1 by E cube means you have to write 3. If it is 1 by E power 4 means you have to write 4. So 1 by E square means write down this 2, divided by, you just go with the minus for this 2 value. 5 lambda minus lambda will give you 4 lambda. Then if you strike this, your answer will be 1 by 2 lambda. Just verify where that answer comes. So the answer comes in option C, 1 by 2 lambda. So I'll just go with one more sum for you to do as a practice. So this is very important. So let me rub the options also, and I'll give you one more sum. So the number is 8 lambda and lambda. And the ratio of A to B is 1 by E. Options are 1 by 7 lambda, option B is 1 by 8 lambda, option C is 1 by 9 lambda, and option D is 1 by lambda. This is very important model, don't forget. So this is in nuclear physics. So let us go for the one more sum in dual nature. Expected 21. In dual nature of radiation. So let us go for the question now. Dual nature of radiations question. So this question is also important. I am expecting so much, especially this model. Coming 12th, September 12th, the exam is going to happen. You can expect this question. So please note it down, the question. The question is, yeah, be in the line. So the question will be displayed within few seconds. Yeah. Electrons used in electrons used in an electron microscope. Electron microscope are accelerated by a voltage of 25 kV. If the voltage is increased to 100 kV, then the de Broglie wavelength, associated with electron the electrons would be option A, option B, option C and option D. There are 4 options in which they will give in the examination. So, let me also write the options now. Lambda 2 is equal to lambda 1 by 2. Lambda 2 is equal to 2 lambda 1. Lambda 2 is equal to 3 lambda 1. So, fourth one is none of the above. So, to do this sum, we are going for only shortcuts. So, what is the question asked? De Broglie wavelength. So, let us take the de Broglie wavelength of these two as, let me take like this, lambda 1 by lambda 2. Take the square root for all the sums in this model. So, what is the second value given? Take this value 100 divided by 25. If we divide it, it will go for 4 times. Then lambda 1 by lambda 2 will become 2 because root 4 is 2. Then if you want lambda 2, I can take this 2 this side and lambda 2 that side. So, lambda 2 is equal to lambda 1 by 2. Just see where is the option. So, the option lies in, the answer lies in the option A. So, it is lambda 2 is equal to lambda 1 by 2. So, let me give you one practice sum for you so that you can do this sum. Instead of this 25 kV, I am going to give 5 kV. This is 25. So, I am changing the options also. Lambda 1 by 3, lambda 1 divided by 5, 3 lambda 1 and none of the above. Please place your answer in the comment area. So, this is a sum for your practice. So, A, B, C, D are given individual nature of radiation. So, this is also an important model in which you can expect the coming NEET exam. So, let us go with the one more one which is important in nuclear physics, So, now let us go for the next question. Before going to the question, let me go with some spectral series of hydrogen atoms. So, without knowing this, we cannot go. Spectral series of hydrogen atom. So, you know very well there are some 5 series. One is Lyman series, the other one is Balmer series. So, this year I am expecting a particular question from this particular series, Balmer series. The next one is Lyman, Balmer, Paschen, bracket. Passion series, bracket series, and finally with fund series. So these are all the 5 important series in spectral series of hydrogen atom. So now we have to know the formula for Lyman series. The formula for Lyman series for wave number nu bar is R into 1 minus 1 by n2 square. So for this, nu bar is equal to R into you know very well 1 by n1 square. So this is 1 by 4 minus 1 by n2 square, and n2 value will be greater than 1. For this, n2 value will be greater than 2, and similarly for nu bar is equal to R into, we get 1 by 9 minus 1 by n2 square. n2 is greater than 3. Similarly, nu bar is equal to R into 1 by 16 minus 1 by n2 square. So n2 is greater than 4. And finally, nu bar is equal to R into 1 by 25 minus 1 by n2 square. So where n2 is greater than 5. So this thing you have to note it down. And similarly, if you want the wavelength, I can also, nu bar can be also written as 1 by lambda. So for Lyman series, I can write like this: 1 by lambda Lyman is equal to R into 1 minus 1 by n2 square. Okay. So now we have written all the spectral series of hydrogen atom. If you require the last line of Lyman series, for example, last line wavelength, let us write down last line wavelength of Lyman series if you require. So I can write 1 by lambda Lyman will be equal to R into 1 minus 1 by infinity square, because the last line is nothing but what? It is infinity. So I can write 1 by lambda Lyman will be equal to R. Then tell me what is lambda Lyman. Lambda Lyman will be equal to 1 by R. This you have to note it down. So what is this lambda Lyman? This is the last line of Lyman series. Last line wavelength of Lyman series. Similarly, you have to find for the Balmer series. This is for Lyman series. Last line of wavelength of Lyman series. Similarly, you have to find for Balmer, Passion, bracket, fund. Let me go for one more time. Last line wavelength of Balmer series. Let us go for Balmer series. Let us go for Balmer series. So for last line wavelength of Balmer series is nothing but, let us write down straightly, 1 by lambda Balmer will be equal to R into 1 by 4 minus 1 by infinity square. So now I can write 1 by lambda Balmer R by 4. So lambda Balmer will be equal to 4 by R. That is 4 by R. Put it in a box. So like this you have to find for lambda, Passion, bracket, fund series. Now let us go for an important question, expected 21. Expected 21 question NEET from nuclear physics. See here, let us go for question number, I think it is 6. Question number 6. The ratio of wavelength of last line of Balmer series and the last line of Lyman series. It's a very important question. is dash. What is option A is 1, option B is 4, option C is 0.5 and option D is 2. So, we have to find the last line. So, you know very well, first we are, let us find the Balmer series. Last line of Balmer series just now we wrote 1 by lambda. What is 1 by lambda? Sorry, lambda Balmer. Let me write lambda Balmer itself. Lambda Balmer will be equal to 4 by R, correct? Then similarly, tell me what is the value of last line of Lyman series. See, last line of Lyman series is lambda Lyman is equal to 1 by R. Then find the ratio lambda Balmer divided by lambda Lyman will be equal to 4 by R by 1 by R. I can divide this and this, so our answer will be 4 by 1, which is equal to 4. So, just see the answer where it lies. It lies in option B. The answer lies in option B. This is also very, very important. Now, I told you how to find last line of wavelength of Balmer series. So, finally, we have to find in nuclear physics the another important model to find out, that is called as longest wavelength. We have to go for longest wavelength of Lyman series. How to find longest wavelength? How to find longest wavelength of Lyman series? See, to find the longest wavelength, first we have to write down the value of wave number of a Lyman series. Nu bar is equal to R into 1 minus 1 by N2 square. So, N2 value you know very well, it is greater than 1 means 2, 3, 4 dash dash dash. So, to find the longest wavelength, first you write down this, note down this value 2 and substitute here. So, we get nu bar will be equal to R into 1 minus 1 by 4. If you simplify this, nu bar will be equal to 4 minus 1, 3R by 4 we get. So, go with 1 by lambda Lyman for longest wavelength. It is 3R by 4. Then what is lambda Lyman? Lambda Lyman for longest wavelength will be equal to 4 by 3R. You put a box for this. It is a very important formula. So, I am just note it down. This lambda Lyman is the value for longest wavelength of Lyman series. Similarly, find for longest wavelength of Balmer series. Let us write down here the next page, longest wavelength of Balmer series. So, first let us write the wave number. What is the wave number for Balmer? It is nu bar is equal to R into 1 by 4 minus 1 by N2 square. The value of N2 you know very well, it is 3, 4, 5 dash dash greater than 2. Now, let us encircle this number and substitute here for finding the longest wavelength. So, nu bar can be also written as 1 by lambda Balmer R into 1 by 4 minus 1 by 9 we get. Take LCM. 1 by lambda Balmer is equal to R into 9 minus 4. 9 minus 4 by 36, which is equal to 5R by 36. If you want lambda Balmer, then your answer will become 36 by 5R. So, like this you have to find similarly for Paschen bracket fund series. Now, let us go for sum number 7, which is very, very important. Sum number 7 is very, very important sum expected in 2021 September 12th. So, expected 21 nuclear physics question, which is very, very important. So, let us go for the last question today's session. Ratio of longest wavelength. Ratio of longest wavelength corresponding to Lyman and Balmer series in hydrogen atom. So, option A it is 7 by 29, option B it is 9 by 31, option C it is 5 by 27, option D it is 3 by 23. See, he has given longest wavelength here of what and what series. One is Lyman, the other one is Balmer. So, just now I have clearly explained you about the Lyman series wavelength. See, green color mark is there. So, lambda Lyman let us write down for longest wavelength. To find the solution, lambda Lyman can be written as, what is lambda Lyman? It is 4 by 3R. And similarly write down lambda Balmer. See, Balmer just now I have written, just I will paste it down in green color. Okay. So, we get 36 by 5R. So, let me divide these two values to find the ratios. So, to find lambda Lyman divided by lambda Balmer. So, your answer will be 36 by 5R divided by 4 by 3R. I can cancel this R and R. So, remaining I will get 36 into 3 by 5 into 4, correct. Then what is the answer you get? So, I can write here 4 9s are and 27 by 5 we get. Okay. Here the question asked is ratio of longest corresponding to Lyman and Balmer. Lyman and Balmer. So, he has given Lyman and Balmer as 4 options. So, 7 by 29 he has given. So, just change the value for Balmer is to Lyman. If you change it, you will get 5 by 27. Just see where that option lies. So, the answer lies in the option C. So, today we discussed 7 important questions which I am expecting in 21, the exam which is going to held on coming 12th. So, NEET. So, please practice these 7 sums in which I have given so important sum in nuclear physics and dual nature of radiation. Only short questions I have given. So, thank you very much for being with me today. So, let us meet again for one more video session in short while before 12th of this month. Until then, bye bye.